This video uses page 38 in your notes, and I'm going to go through the method of factor by grouping. Factor by grouping, and I'll use the initials Fbg, factor by grouping, applies when you have four terms in your polynomial. So you can see in the example there are four distinct terms. So the first thing to do is make sure it's arranged in standard form, meaning the highest power first and all of the powers lined up in order. The second thing to do is determine if there's a GCF which you can remove to give yourself you're working with smaller numbers. And there is no GCF here. So the third thing, group together so that you create binomial pairs. Then you look at each binomial and you remove the GCF within that single grouping. So looking at the first grouping, x squared is common to both terms, leaving behind x plus 7. The whole goal is to look at the second binomial and remove a factor in hopes of having a red x plus 7 left behind. So here, if I remove a positive 2, then what remains behind is x plus 7. And the way that you would present your answer, the common term to both now becomes the red binomial x plus 7. So I write that one time, and the way that I create the other factor, I bring together the two factors in blue, and this gives me the factored version of what I started with. You can multiply through to verify that it works. So x times x squared, and then x times 2, and then I have 7x squared, and then 7 times 2 is 14, which is exactly what I started with, but I would rearrange it so that all of the powers are in order. Let's do number 1 on the next page. It's arranged in standard form. There is no GCF, so let's group this up. And here I have a negative sign, so I'm going to be very careful to place that negative sign inside my parentheses when I group up for that second binomial. When I look at the first grouping, 3x squared is common to both, and that leaves behind x plus 5. When I look at the second group, I need to remove a factor so that what remains behind is a red x plus 5. If I remove negative 2, then I'll be left with x plus 5. And just to check, negative 2 times positive x gives me negative 2x, and negative 2 times positive 5 gives me negative 10x. I don't want to change any of the numbers. I'm just rearranging this so that I can see the factored form easier. So now my common factor becomes x plus 5. And the way that I create the other factor, I bring together the two GCFs that I pulled out. I'll do one more on the video, but that should be enough to give you a model to work with. Let's look at number 3 on the video. It's arranged in standard form. You don't have a GCF. So if I group up, and I'll put the negative sign in the second grouping, looking at the first pairing, x squared is common to both. And that leaves me with x plus 2. Looking at the second pairing, if I factor out a negative 5, then what would remain behind would be x plus 2. So then my factors become x plus 2, and now I have x squared minus 5.